Thank you for the introduction, and it is a great honor to be here. As alluded, that I am leading a team in Microsoft Research working on the large data sets. One of the recent data sets is a collaboration with Allen Institute for Artificial Intelligence, or AI2. And that data set is CORD-19. It is very excited to see that many talks this morning actually utilize these data sets. What I'm going to talk about today is a very important topic that we think is about the corpus biases. And the material has been accepted into a journal paper at the journal Frontiers in Research Metric and Analytics. It's a special issue on coronavirus research landscape, resources, utility, and analytic studies. The abstract has already been online, but we are waiting for the publisher to finish their production process. And so if you would like to have more detail, this paper will actually describe more. And once again, I would like to acknowledge my colleagues at Microsoft Research, as well as AI2 for contributing to these efforts. And not to mention, the Microsoft Research and AI2 are actually two of the participants in creating the CORD-19 data sets. All right, so the gist of the today's talk is actually under a bigger topic that is elaborating about the responsibility that we all have with the society. And as you know, that we are working in the area that nowadays is being called AI, part of the AI, which includes natural language processing. And with the AI being more and more popular and then more and more intertwined into our daily lives, we are seeing a lot of new technology, the benefits that are brought forth with the technologies we have created. But in the meantime, we also see some unintended consequences in many applications. I guess that you probably have all heard some of the horrifying examples being deployed into the system. Microsoft Research had actually one of them. It's a chatbot called Tay that actually quickly learned from the web in all sorts of inappropriate speech. And so that instance actually triggered the society-wide reflection on we are not known to our role in the society. We are not just only technologists creating technology and throwing it over the wall for others to figure out how to best utilize it. Actually, we bear the responsibility of advocating what is the right way to use our technology. And so all these activities started almost a decade ago. Is talking about what is the ethical concern for technologists. We know that all the medical professionals, they have a strong ethical guidelines. It's about time that the rest of us, the technologists, especially those of us in AI, to have the same understanding and to adopt the same ethical considerations in our daily lives. And the topic is broad. It encompasses many sub-areas, ranging from bias, fairness, safety, to transparency and accountability. And obviously, we are not going to cover all of them today. And based on the time we have, we are going to zoom in on the first topic about the biases and what its consequences to the society. And specifically, we are using the CORD-19 that we are actually talking about today as an example. And by leading into the biases question, I would like to highlight that this is no longer an academic exercise. it has come to the popular press, as exemplified by this recent article from Wall Street Journal. Although this is a well-written article targeting at general audience, it actually highlights how important that our technology, the technology we are creating, is impacting the society, and how the problem of biases has already seen tremendous impact on the various scenarios. And although, and this article is amazingly well read, the authors is well read in the sense that actually refer to a lot of scholarly articles in this area. Most of them are actually focusing on computer vision technology, but I hope that once you go through the referred scholarly articles, and you can actually probably using the techniques we're going to show you today to actually to identify the relevant research in the NLP area. All right, so given this background, let's talk about CORD-19. That's the data sets that will be the focus today as a case study in its implication on NLP. The CORD-19 data sets is actually a initiative earlier this year from the White House OSTP, Office of Science and Technology Policy. The problem to solve is to recognize what is the information, typical information overload problem. When the COVID-19 pandemic was announced in mid-January, major publishers have all introduced expedited review process for research on the pandemic. By mid-March, there were already more than 3,500 articles being published per week, and so that's actually the velocity that has actually overwhelmed all the experts. Originally, it was a WHO, but also other many agencies to monitor the progress and the advancements in the research in this area. And therefore, the White House OSTP is issued a challenge to the community to see if we can actually leverage the advancement in machine reading, in natural language processing, like what a lot of technology being reported this year in this conference, and to see if we can actually create a corpus so that the community can build on top of the corpus and assist the experts and medical professionals in handling the pandemic. And you see the first release was March 16 with this and it includes the publisher contributions article, so that we don't run into the copyright and text mining rights issues. But they are also archival services like the bioRxiv, the last speaker which talked about, and in addition, we also we also include medRxiv and archive and other relevant material sources. And the idea of this corpus was actually putting on the challenge on Kaggle, hosted by Kaggle, to challenge the community and in general to develop a question answering bot that actually can mine through the data sets. And also another speaker earlier this morning talked about at the track, the premier information retrieval conferences run by NIST to see what kind of advanced search technologies, retrieval technology can be developed based on the data sets. And the data sets have been downloaded quite actively, are being used actively. And this is, and some of the results are actually presented this morning. So we are very glad we can do this. The methodology as described by the paper shown on here, which was available in ACL earlier this summer, is actually originally quite very straightforward. We utilize these keywords, keyword query, into multiple databases. Most importantly is the PubMed Central, PubMed and PubMed Central, to retrieve all the relevant documents that we think may be helpful for the COVID-19 the research. And earlier there was a question about why COVID-19 is a new phenomenon, and some of the papers are actually dated back before 2019. This is because the query, the literature we would like to include actually encompasses all the coronavirus disease as well. So it actually dated back to late 60s, right? So the methodology here, it originally is using query, and then we know that the search query and also the search systems may have a different kind of flavors in presenting their results. So in the very beginning, we know there are certain potential biases that this methodology can lead. And so as a great citizen of ethical AI, we feel we are obligated to study the issues and to share the findings with the community so that we know what kind of biases in the data that can have potential impacts to the downstream technology development, such as the entity extraction, information extraction, search technology, or any analytical studies conducting our database. One of the principles for the ethical AI is to recognize that biases are probably not entirely avoidable. And the most important thing then is to make explicit of your underlying assumption. So our assumption in assessing the corpus is that we can actually leverage the crowdsourced material to establish the baseline from which we can compare against in terms of biases. And the crowdsourced material that we're talking about actually is quite straightforward to obtain because of a special property of a scholarly article corpus in the sense that most of the scholarly articles would actually cite other prior arts to establish their backgrounds and to have a good survey of the state of art by the time of publication. And this is actually a well-established practice pioneered by Price in 1965. It's a groundbreaking paper, Networks of Scientific Papers, in which Price was the first to indicate the value of a citation network and how it can be used. His colleague, Eugene Garfield, has consequently established an institute that becomes a Clarivate today. They are the pioneer for half a century, and today we are all utilizing the many insights of the have derived from the observations described in the network science. In this work, we are also leveraging the insights and the consequent work derived from that paper. And the idea, amazingly, what a lot of a theory has been developed to explain and actually prove that certain phenomena are actually quite commonplace in the network science, but not only in the network science in general, but also to the citation network in specific. In this work, we specifically has built our foundation based on the four major prior arts. The first one, of course, is the preferential attachment, or better known as the rich gets richer, by Barabasi and his colleagues, published in 1999. It basically means that the better cited papers are going to cite more, and so this is actually a widely reproducible observations in the network. And we are going to show you why this is actually important in the work. And the original, the preferential attachment theory have been revised several times. One of them is the individual node fitness. So it's not to explain why you have this preferential treatment attachment. Another explanation to see the networking effect is that when you are trying to cite, you actually want to cite a better one, and to better contents that matched what you are trying to explain. And we also take that as a underlying assumption in utilizing the theory to the citation network. And they are further down the road is that they are more a mathematical model, more formal mathematical model to describe, trying to put an analytical framework to the phenomenon, and we actually adopt them in this work as well. And specifically, this is actually a rich body of literature in that. And so the methodology that we are going to present specifically utilizes two methodology. The first one is the enclosure graph that was pioneered by Sinatra and her colleagues in analyzing the physics literature for almost 100 years of collection. And in that, they utilize the similar methodology in this to understand what kind of physics research trends can be observed from literature, and if there are any sorts of important implications for the development of physics. And in addition, as I will be sharing with you, the enclosure graph in this work can actually be extended to the work that we are proposing in the ended up using in for CORD-19, and that's the concept of closure graph. And this is the bulk of the work that we are going to share with you today. All right, so before I go to talk about closure graph, let me first talk about enclosure graph. That was the prior art. And the idea is pretty simple, that you started with a seed collection, like the case of a CORD-19. In the original is actually a manually curated sets of paper from physics literature. And then they analyze their citation relationship. They expand the cited, and so this is the cited paper from this seed collection. And also, they also trace back to see what other articles are citing these seeds seeds documents. So it is actually utilizing a network science terminology. This is a single step bi-directional walk of the graph. So by starting with any initial condition, by walking one direction toward citing and cited, you can actually enrich your corpus with additional document. And they utilize and the result of the collection is called enclosure graph in this work. And so this methodology has been shown to be very powerful in analyzing the physics literature. However, when we try to apply this methodology to assess the CORD-19 data sets, we found that it has actually a very interesting side effect, especially in the case that the research in the COVID-19 research has become more and more interdisciplinary, and therefore a lot of C papers in the CORD-19 actually are citing the articles, for example, in computer science, such as utilizing computer vision for reading X-ray or other medical imaging thing. And therefore, you will see a lot of cited papers are actually the tool papers. What we computer science consider as a tool paper, how you can actually using the technology developed for ImageNet for particular study like a genome sequence and things like that, right? And therefore, when you actually derive that, and a lot of time, and this technology would actually cannot be actually iterated from single step to multi-step, because if you actually treat this enclosure as iteratively as a C document and try to do a single step walking in the citation network, some of the paper which are which is, for example, like this one, ImageNet classification, is actually more widely cited by computer science that has nothing to do with COVID-19. The enclosure you get immediately get a very go off topic very quickly, right? And so so to accommodate this problem, we also observe another potential issues with this technology, that is the quality of the seed. The reason you want to actually expand your corpus from initial selection a little bit is that the seed selection actually have a selection bias. And so by leveraging citation, which are from the community judgment in general, you can probably balance this initial selection bias. But unfortunately, you can actually not iterate this through the multi-step. So how do you know when to include? Why not including the article being cited by the cited or the citing the articles, right? And so this is the question that early on, when we apply this methodology in assessing CORD-19, we ran into this situation. In the following, when we present the empirical evidence for bias, we're going to call the expanded collection of documents based utilizing CORD-19 as a seed as CORD-19E, where E stands for enclosure, right? So having noticed that the enclosure graph, when you have the bidirectional work to the site of the citation, would actually lead to the off-topic articles very quickly. We then switched attention to another technique called closure graph. The idea of the closure graph is actually unidirection by recognizing the citation relationship in the network terminology is actually directed edge. And so there's a way that just A cited B and B is actually different thing as B citing A. And so the question here then is that can we actually balance the initial selection bias by actually following all the citation, the crowdsource, the crowdsource selection criteria from the general scholarly literature, and actually trace the citation all the way through till that every articles that is ever being cited by other would be also in the set. And so that's the very straightforward idea of a closure graph, to ensure that all the citing, all the references, all the articles being referenced in any member of the document in the corpus would also be in in the closure in the corpus. And so that the result of this kind of expansion is something we call closure graph. And so in network science terminology, this is actually unidirectional, multi-step, and there's a guarantee that it will converge. It won't go indefinitely, and the motivation is what we talked about, that if most paper follow, if the most citation really follow the fitness or preferential attachment theory as talked about earlier, then by expanding by working through the network citation and expanding the document collection this way, we can actually include comprehensively all the material related to the topic of the seeds. But there's no guarantee, right? And so a key important thing that we are going to show you is how effective this is, what kind of a topic overall may be actually there, and a surprising finding in this study is that even though the theory based on the no fitness or previous network science theory suggests that you actually want to run the iterations to the full closure. In fact, if you're in many analytic tasks, you don't need to have a full closure. Actually, what we found is a midpoint called inflection point seems to be able to capture a lot of results that you would get from the closure already. So in the following, when we present our finding, the full closure, the document sets result in the full closure computation will be called CORD-19C, where the partial closure or stopping at the inflection point is called CORD-19I. All right, and so here are the statistics based on, we ran this study back in April. At that time, the entire CORD-19, the size of a CORD-19 had the 48,000, slightly more than 48,000 article. And when we run the closure graph, run the closure graph iteration, it grows really, really quickly. So by the time you get to the third iteration, it's already north to 20 million articles. So it's actually 500 times more than original one. And when you run it to the convergence, all the way to the convergence, it's a 60 million. So it's actually more than 3 orders of a magnitude larger than the C collection of CORD-19, right? And these are the bar, the solid bar here are the paper count. And if you look at, so that actually, if you think in terms of a citation network and treat each paper as a node, then these are the number of nodes in the network. The network also is actually edge heavy, meaning the citation relationship constitutes the largest, the bulk of a network. And if you analyze them, you can find out that the citation in terms of a relationship, in terms of edge, is also growing very rapidly. At the third iteration, you are already seeing more than 700 million citation being observed, and all the way, if you compute it all the way to the closure, it's closer to 1.2 billion citation relationship, distinct citation relationship. All right, and so a way in the network science to see how well the off-topic how well you are on topic to the original one is called embeddedness, and it is actually a prior art developed by the network theory to see how many citations you receive from the collection already. So the zeroth iteration is the CORD-19 itself, and if you analyze the citation to the CORD-19 database, you'll find that 71% of them are actually receiving citation from within the CORD-19 already. But as you can imagine, as you expand more and more, you're including more and more older articles as well as other articles. The percentage drops down, and that's actually totally expected. And so the most important thing, of course, that we wanted to understand if there's whether the topic coverage is actually close to each other. And here, the topic, we utilize a topic model technique in very straightforward in the NLP literature described in the Microsoft Academic Graph literature. It's a combination of using keyword as well as word embeddings to automatically learn the topic and create and run the hierarchical topic modeling techniques. It's not unlike to the common common techniques that you will like LDA that kind of algorithm. And so these are actually the top level of the topics. In the CORD-19, half of the literature is actually in the biology domain, 38 from medicine. Chemistry is very underrepresented in 4%. But by the time you actually reach to the 3 iteration, this is actually the inflection point that we talked about. You actually see that the composition of relevant articles being cited for COVID-19 research, chemistry actually plays a very important part. It should be 20%. And by the time you reach the foreclosure, you see the area of biology, medicine, and chemistry are almost equally represented. And so this is actually a early evidence to show that there may be some underrepresentation of chemistry journal, chemist articles in the CORD-19 collection. And in terms of age distribution, this is actually, we also look at the age distribution based on the publication year of the articles. And the CORD-19 is actually this one, the jacket one. And not surprisingly, because the majority of a CORD-19 is talking about COVID-19. And so the articles tends to be very close to 2020. In fact, this is actually the bulk of the article being included. This may be also a side effect of the methodology of utilizing a search engine to identify potential articles to be included, because search engine typically would take the recency as important features in their ranking. But if you actually follow the expanded data set, either through the enclosure, the closure, or even just, the inflection closure, the full closure, or the enclosure, you will find the majority of the knowledge that we actually the scholar derived is actually dated back mostly a decade before. Here, there's actually a potential issue that the citation is actually age biased, and we recognize that because it takes longer, it takes a while for the new article to gather its due citations. But nevertheless, a lot of the percentage of articles from the past decades actually plays a key role in understanding the pandemic of today. Again, the citation counts has the age bias. So here we utilize another metric developed in Microsoft Academic Graph that has effect of adjusting age bias, meaning that we actually are utilizing the search engine technology to balance instead of using citation that just reports what has already happened. The saliency metric is trying to predict how widely cited a particular article will be in the next 5 years. And by doing this, a separate study has found that, being a link here, have found that the salience metric is actually a complementary measurement to indicating how important an article would be, regardless of how old it is. And so here's the result. You see the citation in the citation trend is in dashed line, whereas the salience trend is in the solid line. And you can see there's a upward shift to a more recent article, to a more recent one in the saliency metric than the citation one. Still, though, the majority of the high saliency articles are actually in the decades forward, rather than the as indicated by CORD-19, where a focus is on more recent article. Right. And so if you wanted to use the CORD-19 database to assess journal and understand what kind of journal you should follow, it turns out that you probably also will get very different answers. In the CORD-19E, you will see that the majority of the here we are showing the article count and citation count in the for different data sets for different expansion, and it's the access, the journal is ranked based on the importance of the journal derived from CORD-19. And you will see that according to CORD-19, the very important journal is actually the Journal of Virology, and followed by PLOS One and PNAS. The funny thing, however, that if you follow the CORD-19E, they don't agree. The trend is actually not agreed by just expanded into enclosure graph. Similarly, when you compute the saliency, not just a citation, the disagreement is actually quite significant. Similarly, when you compare CORD-19 with the closure graph, the disagreement are actually more dramatic. Most importantly, based on the closure graph, it looks like in the early literature, it's already some of the scholar already identified that CORD-19 is not just a respiratory disease, but it can also have a impact in the circulation in the heart, at the heart. Those articles are not included in CORD-19, but it actually is it's observed in the expanded data sets. And recently we found, and again, this study was conducted in April, and recently when we checked again, indeed, there are actually more and more literature included in the CORD-19 that includes this area. So we are very excited to see that the expanded data set can actually provide a early indication of what is missing in the core data sets. If you wanted to study where the activity happens in the world through from different region, it looks like the CORD-19 would also give a slightly different answer than the expanded data sets, and in fact it would emphasize a lot of activities in the America and Asia, especially from China. But if you look through the expanded sets, it actually is more, the contribution from Europe is actually more acknowledged. So
sorry
again,
to interrupt you,
yeah.
Kuansan.
Yes.
How many slides do you have still?
This is actually 3.
Okay,
Right.
fine. Sorry.
Right. So again, this is just a different way of representing what we talked about in the previous slides. In terms of team size, though, so we talked about the disagreement with CORD-19 and the expanded sets. However, if you want to study the collaboration in terms on this research, CORD-19 actually is not bad. And so it actually in talking about the size of the team and their impacts. And so the sampling technology in CORD-19 is actually quite consistent with the expanded data sets. So the takeaway is there are several things. The sampling technology like CORD-19 is already a good thing, good to do, but there are many areas that the bias in the database can be observed against the expanded data sets. And so when you try to utilize the CORD-19 alone, one has to be careful what kind of a task you are going to derive, and what kind of conclusions you are going to derive from the data sets, because the data set does have a disagreement with the expanded data sets. And so the closure graph supports many network science theory. Most importantly, it's a preferential attachment with fitness and things like that. And even though the theory says that the closure graph, you have to run it through the closure, but what we found is actually in the midpoint on the third iteration, it seems to be good enough in many cases when you try to do analyze. And if you remember previous slide, the enclosure graph is actually a fraction of the size of the closure graph. So it's easier to deal with, and you are probably not losing much. In the future study is there are possible several future study direction, one of which is the citation. Currently, we are only looking at the citation relationship. We're not looking into citation, nature of a citation, whether it is actually a citation mention or is actually really supporting or actually counter arguments in that. This work has not studied into this in analyzing the potential biases, but this is actually a worthwhile effort to go into. Again, all the resources are available on GitHub. You are welcome to take a look. And as I already running short on time, I will stop here and take questions if there are. Thank you.